Page 3 says, use the triangle in diagram 1.3 for problems 6 and 7. And the first question, number 6, says, find the value of j, round to the nearest tenth. So we know an angle here already, 72. It's 72 degrees here. And we want to find out what j is. So the perspective to 72 is j is going to be the adjacent. And now we need a known. Well, we have our variable k here, so we can't use that. We do have a known with 8, which would be the opposite in the perspective of 72. So, again, looking at sine, cosine, and tangent, what uses opposite and adjacent? Well, the tangent does. So if we take the tangent of 72 degrees, that will equal the opposite over adjacent. And the opposite over the adjacent. And in this case, the tangent of 72, if we look in our ratio of trigonometry values, tangent is going to equal 3.0777. The opposite is 8, and the adjacent is j. So we're almost there. Now we have known values for the left side of the equation. We have a known in the numerator and our variables in the denominator. So let's isolate the variable first. Since 8 is in the numerator, if we want to isolate it, we need to multiply by its reciprocal, which would be 8 in the denominator. So these would cancel, and you're left with 1 over j. Important to remember that that j does not move up into the numerator. Many people often make that mistake, that they throw the variable into the numerator. But you have to keep it there. So on the right side, you're left with 1 over j. On the right side, or on the left side, you're left with 3.077 over 8. Again, 8 is in the denominator. Now we know that there's a mathematical law that allows you to take the reciprocal of the left side and the reciprocal of the right side, and they'll still be two equal values. So let's do that. So we'd be left with 8 over 3.0777, and on the right side we'd be left with j over 1, or I'll just notate it as j. So if we simplify with our calculators, 8 divided by 3.0777, you're left with 2.599 and some values equals j. And since the problem says round to the nearest tenth, we would see that we would need to round to the nearest tenth. We look here, and we would round the tenth number up to 2.6. So j equals 2.6. Now, we could plug this value of j in for problem number 7 and use the Pythagorean theorem. But we need to remember that when we took the tangent of 72 degrees, this value is a rounded value. So we rounded in order to get that. And then we have to remember that our answer was also a rounded value. So we've rounded two numbers already. So our 2.6 is not a very accurate number. So if we put it in the Pythagorean theorem, we wouldn't necessarily have a very accurate answer. There would be a lot of room for error there. Also, if we use the Pythagorean theorem, 2.6 squared would give us a decimal, and we don't know how to take the square root of decimals at this point. So it's best to continue to use the same method that you used in number 6. So what we have to do, the only difference is our perspective of k. All right? So instead of using the tangent, we would use the sine, because we have to find out k, which is the hypotenuse. And we know that the sine is the opposite over hypotenuse. So we take the sine of 72 degrees equals the opposite, which is 8, over the hypotenuse, which is k. So again, we've created an equation where we're left with only one variable. The sine of 72 is 0.9511 equals 8 over k. We, again, would like to isolate the variable k, so we have to get rid of the 8 in the numerator. We multiply by its reciprocal, which would be 8 in the denominator. These cancel, and I'm going to use the right side. So we are left with 1 over k equals 0.9511 over 8. Again, we're going to use the reciprocal of both sides, and you're left with 8 over 0.9511. If we use our calculator, we end up with, and I'm going to erase this a little bit, so 8 divided by 0.9511 leaves us with 8.4113 ... some numbers equals k. If we round to the nearest tenth, we would be left with 8.4 equals k. Okay? Page 4. Page 4 says use the triangle in diagram 1.4 for problems 8 and 9. In the diagram,